Welcome back for more work on the commutative property. So in lesson 7, we learned that multiplication has turnaround facts just like addition does, and we showed that using arrays, specifically um, using the factors 2 and 4, and then 2 and 6. And we showed that if you rotate your array around, you don't add or subtract anything from it, and you just switch the order of the factors, and your answer stays the same. We're going to continue that work today in lesson 8. We're just going to use at least one factor that's 3 in our problems. So increasing the complexity a bit there. And then we're going to do a count by or skip counting before we draw our array. If you remember from lesson 7, we drew the array first and then we did the skip counting. Well, today we're going to switch that up a little bit and we're going to do the skip count first. So, to get started with that, let me share my screen. Here we are. So I might ask you to do a skip count by 3s, and I'm going to count by 3s up to 12. So 3, 6, 9, 12. Okay. So I have groups of 3, and I end up with 4 groups. So my array then is going to look like this. 1, 2, 3, 4, because I have 4 groups, and each group has 3 in it. Okay. So if I'm counting by 3, the size of my group is 3, and then how many times I count by that thing is my number of groups. So I have an array here, a 4 by 3 array. And then what we can do, just like we did last time, oh, sorry, I'll write the multiplication sentence for that as well. So the multiplication sentence there becomes 4 times 3 equals 12, right? And then we'll rotate our paper, rotate our array around. And now I'm going to, I can skip count now the other way. I can go 4, 8, 12, right? So I have 4, 8, 12. And my multiplication sentence becomes 3 rows times 4 in each row equals 12. So again, my 12s remain the same in both of these. 4 times 3 equals 12, and 3 times 4 equals 12. Same exact concept as in lesson 7, just using factors, including the factor 3 in our multiplication sentences, and doing the count by before we draw the array. Let's do one more. Flip my paper over here and we'll do one more example. So we could have a situation where I say count by 3s 5 times, and you would do, let's do 6. Count by 3s 6 times, and you would go 3, 6, 9, 12, 15, 18. 1, 2, 3, 4, 5, 6. I've counted 6 times. So my array then looks like 6 groups of 3. 3 groups, 4 groups, 5 groups, and finally 6 groups. Okay. So my multiplication sentence, I have 6 rows, so 6 groups times 3 in each group leads to a product of 18. And I know that because I counted up to 18. That's the total number I have. Then the commutative property, which tells us that we have turnaround facts in multiplication, says we can rotate our array and now count by 3. So by 6s, I'm sorry, 3 rows of 6. So 6, 12, 18. So I then have a sentence that looks like a multiplication sentence that looks like 3 rows times 6 in each row equals 18. And once again, I've shown that you can switch the order of the factors and the product will remain the same. The answer stays the same. Again, we don't add or subtract anything from our array here. And again, that is the major point of these 2 lessons. And it is what I want you to understand about the commutative property is that in multiplication, you can flip the order of the factors and leave the product the same. If you can understand that out of these 2 lessons, then you are really going to be able to move forward with a little bit more ease in multiplication. We will move on to some other properties of multiplication in the next few videos, and I hope that you're finding a lot of success here with the commutative property of multiplication in lessons 7 and 8. Again, if you have any questions, don't hesitate to ask.